Hello class, we're bringing it all together in section 6.6. We're connecting linear relations that we've been doing since chapter 5, and we're looking at growing patterns that we've been kind of focusing in chapter 6. Really, if you think back, if you remember at the beginning of this topic, I said there's going to be four ways you can represent linear relations. You can represent it through equations or pattern rules. You can represent it through table of values. You can represent it through graphs, and you can also represent it through stories. So that's the four things that we're going to tie in together in section 6.6. You have done a lot of things, whether you believe it or not. You've done a lot of graphing, you've done a lot of diagrams, a lot of patterns where we drew tiles, definitely graphs, and definitely pattern rules. We didn't really talk too much about stories, but you have read stories as you know, introductions to questions, so it's not going to be anything new. One of the most important things is that in the last sections we connected the pattern rules with the equations, and I guess this is what they came up with: y equals mx plus c. Really, this is what we're going to follow: y equals mx plus b. That is a very important equation. It represents all linear relations, so all straight lines. This, if you remember, that is their multiplier or rate of change. I'm going to write it, rate of change. There you go. B, if you remember, it is the constant. So we can write constant. It is also called y-intercept. If you remember, that is the where the line kind of crosses the y-axis. So y-intercept. It is also sometimes called initial value. Initial value has a bunch of names. And then we have x and y. X and y are just variables. However, if you remember, x is the x-axis, y is the y-axis on a graph. If you remember, x-axis is reserved for independent variables. Independent variables. So this is things like position number, because we did position number, number of tiles. Time is usually an independent variable. Things like that. Things that don't depend on other things. We mentioned that in previous sections. And the y is the dependent variable. Y depends on x variable, so dependent variable. There we go. Oops. There we go. So that is a very important equation. They're using C here for constant. I'm not going to use it. I'm going to use B because B is um, more common. You will see this in grade 10 and pretty much other math courses after that. All right, so this is where we're going to connect everything. So here's their example. They have Serge is laying black and white patio stones in a pattern at the entrance to his garden shed. He needs to extend his pattern to 10 rows to finish the job. He estimates he has enough stones for 9 rows. So here's his pattern. It seems like he started with 2 black ones, 3 white ones, and then it's increasing. So as you can see, he just increases by 2 every time. He adds the 2 stones at the end. So from here to here, there was in total, it started as 5 stones, and then there's 1, 2, 3, 4, 5, 6, 7 stones, so it's plus 2. And then again it's plus 2, and it keeps going, plus 2. So that is the pattern, and you can see that how that reflects in the table of values. So you have row 1 has 5 stones, row 2 has 7 stones, row 3 has 9 stones, and so on and so on. And they do calculate the first differences just like we did in the previous section. We determined that first differences are 2. And remember that 2, this represents our multiplier, or this represents our rate of change. So we know right away, I'm not going to scroll down and look at the answer, but we know right away that we're going to have something like this: y equals 2x, and then plus some kind of a constant. How do we get a constant? Well, if you remember, constant is the zeroth term or zeroth row here. So I'm gonna add it in by subtracting 2, going backwards. I subtract 2, which means I'm gonna have 3 tiles. So that means it's gonna be 2x plus 3. So that's my equation. That's how we're gonna derive equations from the information that's given to you. As you can see, the story was given to us. So that's the story aspect that I was talking about. And then it says, A, how many more stones does he need to buy for row 10? So really, we need to calculate when x is 10. So there's their equation. They have the same thing, 2x plus 3. And in this case, it says row 10. That means that x is 10. So all we're doing is we're substituting that value 10 instead of x, calculating, and it says 23. So we're going to need 23 stones in row 10. So that's pretty wide. I'm not sure why she's doing this pattern, but it doesn't seem practical. In any case, that's how we're going to do it. So you create an equation, you can substitute some things, and estimate, and that's it. I guess I should rephrase that. We're not estimating this case. We were estimating when we were using graphs, when we were doing interpolation and extrapolation, but in this case, we are getting the exact value. So when you use these equations or pattern rules, you are actually given the exact value. There's no estimating there. All right. B, oh, sorry, I didn't read B. BBB said, how many stones of each color does he need in row 10? So let's skip there. So as you can see, white stones in a row is +2, and black stones is row is +1. And then what they do here is they just kind of keep adding, I guess. Let me just pause that so I can. Oh, okay, so I just checked out their solution. So what they did is they kind of looked at it and they said, okay, row number. If I add 2 to the row number, that represents my white stones. If I add 1 to the row number, that represents my black stones. Where did they get that? Well, if we go back, here's my row number. In row number 1 here, um, in row number 1, I have 2 black stones and 3 white stones. So that means row number 1 plus 1 will give me black stones, and row number 1 plus 2 will give me white stones. So that's where they're coming from. They just looked at the pattern and then kind of determined that. So in the end, because it's the 10th row, they add 2 for the white stones, which gives them 12, and they add 1 for the black stones, which gives them 11. So there's other ways to do that, but I'll just defer to this one. All right, so let's do this question. So it says write a story problem for each graph. So here's 2 graphs. So we're given some information. If we look at these graphs, here are the important things that we need to look at. First thing is we're going to look at where does it cross the y-axis. So this one in A, it touches on it at 0 value. So y is 0 here. So I know that my b value, b, is going to be 0. Second thing is I'm going to look at the rate of change. So if I look at the rate of change, remember from a graph, you pick 2 points and then you do rise and run. So I'm going to write that m equals rise over run. And I'm going to pick this point, 0, 0, and I'm going to pick this next point, which is 1, 3. So my rise, my vertical increase it goes from 0 to 3. So 3 is my rise. And horizontally, it goes from 0 to 1. So be careful not to count the squares, because sometimes in this case, if we look at horizontally, 1 square represents a half. So actually look at the values. Look at the values from, it's going from 0 to 3 and from 0 to 1, not the squares all the time. Sometimes it's going to work out, like in this one, that 1 square is 1 measurement up, but it's not going to work out all the time. So in this case, rate of change is 3. So our equation is y equals 3x plus 0. Okay, so what could this be? That means that values are increasing by 1. So you can write some kind of a tile story. You can say that for every position, for every position, number of tiles increases by 3. Now this is nothing fancy. We can go and make up a story just like in the previous one where there's a solution. So we can say, you're laying patio stones, and in the first row you have a certain number, in the next row you have a certain number that increases by 3, that sort of stuff. So you can make up a story like that. All right. Next one, again, we're going to look at two values. So the first one is where it kind of not crosses. In this case, it doesn't. You can't see the crossing, but where it touches the y-axis. So that's at 6. So I know my b value, my constant, is going to be 6, my y-intercept, and I'm going to use this point and the next point. So my rise, in this case, it goes from 6 all the way to 8. So my rise is 2. And for my horizontal movement, it goes from 0 to 1, so my run is just 1. So I know that rise over run, I'll write it again, that's an important thing, is 2 over 1. There we go, that's equal to 2. Nice. So we can write an equation, y equals 2x plus 6, and now we can make up a story. So a lot of times you might see a story in terms of um, uh, like salary, sales, or something like that. So this could be some kind of a cab story. So I don't know how much you take a cab, or Uber is a different thing, but I'm really talking about a cab. But hopefully you've seen it where when you step into a cab, there's already a certain amount that they charge you just for stepping in. So you can say, as you get into the cab, you're paying $6, and then for every kilometer, you're going to pay $2 more, something like that. So that can be a story. I'm not going to write that down, but you kind of get the gist of it. And that's kind of usual question that people go to. All right, moving on to next one. Here we go. Here's the story. So the story is at Paolo's Pizzeria, each square table can seat 4 people. So there's the table here. We have 4 chairs around it, seats 4 people. It says complete this table of values to show the number of people that can be seated if the pizzeria has room for up to 5 tables. So here we have a story. We have some kind of a visual representation. Now we're going to create a table of values. So I know that if I have 1 table in this Paolo's Pizzeria, I can sit 4 people. If I get 1 more table, so let's say here's my big table, I know that this table is also going to have 4 chairs. There we go. So that means that if I have 2 tables in my pizzeria, I can seat 8 people. And hopefully you can see the pattern that if I have 3 tables, it's going to be 4 more people that I can seat, so 12. So you can see that it's increasing by 4 every time I add a table. So that means for the next one, it's going to be 12 plus 4, which is 16. And next one, 16 plus 4, which is 20. So this is how my projections are going to be for the number of people that can be seated at this pizzeria. All right, so we've created a table of values. Let's see what it says. How many people can be seated if there are 0 tables in the pizzeria? Provide your reasoning. I'm going to go back. I'm not going to, maybe I'll write it here in B, but I'll go back to the table of values. Remember, 0 table is up here. I'm going to add it. 0 tables. I'm working backwards. Instead of adding 4, I'm subtracting 4. 4 minus 4 is 0. So not surprising that if you don't have any tables that have chairs around them, you're not going to have any people. So you can't seat people. They can maybe stand, but they're not going to be sitting. So there's my reasoning. I kind of showed it on the other end. It says write an equation to show the relationship between number of tables, which is the independent variable x, and number of people that can be seated, which is y. So remember, our equation is going to look something like this. Y equals mx plus b. Remember, b is the constant, or if you remember, that is the uh, value at 0th term. So here's my number of tables 0, my y value is 0, so that means b is going to be 0. So b is 0. My m is the rate of change. You might have noticed it, that the number of people increases by 4 for every table, so that means my rate of change is 4. So that means my equation is going to be y equals 4x plus 0, but we actually just write it y equals 4x. We also call this kind of equation a direct um, a relationship because there is no, the initial value is 0. So anyways, we'll talk about that more in the next chapter. And then it says if Paolo expands his pizzeria so that 15 square tables will fit, how many people can be seated? All right. So they're telling us, okay, X, we have 15 tables. So I use my equation, 4x, and I know that x is equal to 15. So I'm going to substitute y equals 4 times 15, and I'm just going to solve it here. So how do you do this simply? Well, you know that 2 times 15 is 30, and then times 2 is just going to be 60. So this is pretty large pizzeria. You can seat 60 people. All right. Um, Next question. Two children and some adults are hiking in Algonquin Park. They come to a wide lake. They must cross using a small paddle boat that is beached on shore to continue on the trail on the other side of the lake. The paddle boat can only hold two children or one adult and one child. It is not big enough for two adults. Both children are very good paddlers, as are all the adults. Okay, so this is a weird situation. We're going to say, okay, you can only go one way. We're counting going across one way. We're not going back and forth. So it says complete the table of values, show the number of trips needed to cross the lake for each group. So number of adults with two children. So if I have one adult, how many trips am I going to take? Well, it's going to be one trip because I can take an adult with two children. That's the option. Where is it? Oh no, it's not. It's one adult and one child. One adult and one child. So I changed that. Let me just erase it. There we go. So I'm going to change that. So it's not going to be one trip. It's going to be two trips because I have to go one child, come back, and then second child. All right. So number of adults, 2. So in this case, yeah, this is where it gets a little complicated. Do you count going on the back? You know what? I'm not going to go on this question because this question can get a little complicated because there's not enough details. So I'm going to skip this one. There are going to be many other better examples than this. So what you can do is, yeah, just do one of these practice questions. And that's it for this lesson. If you have any questions, please send me a message. Thank you.